Okay, so we're asked in this example to find the sum of the given series. Now it looks pretty daunting on the surface, but let's try and use what we've come up with so far in the lecture. So we have, for all x element of R, sine x is equal to sum n equals 0 to infinity minus 1 to the n over 2n plus 1 factorial times x to the 2n plus 1. Okay, so let's have a crack at rewriting the series we were given, which was minus 1 to the n pi to the 2n plus 1 divided by 2 to the 2n plus 1 times 2n plus 1 factorial. Rearranging this, so I'm not going to do anything, I'm not going to change anything, I'm just going to rewrite what I'm given for the terms, bringing the 2n plus 1 factorial under the minus 1 to the n, pi to the 2n plus 1 over 2 to the 2n plus 1. Now the pi and the 2 are both to the same power, so I can bring them inside the 1 power, so minus 1 to the n over 2n plus 1 factorial, pi over 2 to the 2n plus 1. Now, this equals, if I call the above equality star, if we stare at this, we can see that the sum we have now actually just equals sine of pi over 2. It's exactly the same as the equality above, except instead of an x, we have a pi over 2. And sine of pi over 2 is 1. So, this is a very useful application of Taylor series. If you were to look at the series above and try to compute the limit just based off the partial sums, trying to find patterns in partial sums, that'd be absolute hell. So Taylor series has been very useful in just simplifying this argument greatly, and we find that the limit we were looking for is just 1.